Okay, so I need you guys to recall a skill called the AC factor method. Okay, the AC factor method, which you might or might not have learned under that name. Okay, so please note I have here a quadratic which is in what form? Nice try. This is not factored form.
Oh, because it doesn't have a 3x?
Yeah, because there's a 3x in here, right? The factored form for this would be to factor a 3 out of that first term, or that first factor. So if you wanted it in factored form, it would be 3 times x minus 2/3 times x plus 7.
Fair.
You guys with that? Like, that's the factored form. This is like almost factored form.
Yeah.
Right? So this is a convenient intermediate step for me to have. So what I want to remember is a way to get to here from standard form. So to illustrate that, I want to just go backwards quick. So to get from here to standard form, what do you do?
Foil.
Multiply that junk out. So if I FOIL, right, this is like almost factored form.
Almost in the counts for first ingredients of factoring quadratics.
Yeah, totally. Also nuclear weapons.
Almost in the counts.
Okay. So, almost factored form, FOIL this out, what do you get? Q of x is,
3x squared.
okay, there's definitely a 3x squared.
Plus 21x minus 2x.
Let's see,
so 19x
I
plus
think I got a minus 2x plus 21x is
19x minus
19x
minus 14.
minus 14. Okay. Now, I want to illustrate where something came from. So I'm going to go back and think about that 19x. Where did the 19x come from?
When you subtracted the 21x from the 2x.
Yeah, I combined the 21x and the 2x, right?
And
You guys
then
see that?
and
So what I'm building here, now I'm in standard form, right? And I want to figure out how to back out of this. Like I want to know how to get back.
do that square method. Is that the thing?
So in getting back, I'm going to write in a different color. The first thing you want to do is to magic with numbers, which I'll tell you in a second. But you want to think about this as plus 21x minus 2x minus 14. So the magic thing I did was I looked at this guy. So I looked here at my equation, and I looked for two numbers. And those two numbers had to add to 19 and multiply to 42. Two numbers that add to 19 and multiply to 42 are 21 and 2, right?
Yep.
To get them to add to 19, the 21 has to be positive and the 2 has to be negative. And that jives with the multiply to negative 42.
Yes.
You might spend a second to check that signage.
It's like the thing you do with like the.
Yeah, some people do this with this
Yeah.
kind of this thing.
Yeah.
Yeah.
That's what I learned.
So with the like this thing,
Mhm.
yeah, go ahead.
It's just a visual map of the same thing.
Yeah. It's just the exact same idea visually.
Mhm.
So get your two numbers, replace your middle number with those two numbers.
Mhm.
Right, so you rewrote B. And then we should, and this is the weird bit, factor as much as you can out of each part. Each part being the first two terms and the last two terms.
Alright, so factor 3 out of this one.
So out of these first two guys, I can get a 3x. What are you left with?
X plus 7.
An x plus 7. Hey, I remember having an x plus 7 a while ago. Right? And then there's a minus, what can you get out of this guy?
Minus 2.
Minus 2, what are you left with?
X plus
Minus 7.
7.
X plus 7.
It's like the same.
Multiply it out if you're not sure to check. Right? Make sure you get your signage right. It would be a big clue if these two things were different, that something has gone badly.
Okay.
Whether that's arithmetic or picking the two numbers or something. if these two guys, right, if these don't have the same thing in parentheses here, you have dorked something.
Okay.
Cool?
Okay. So you
All right, and now you,
combine the outside, the coefficient things, and then yes. And then
yeah, so now you can either think about this as factoring out an x plus 7 from both things, or you can think about it as you have 3x of this stuff, and then you took 2 of that stuff away. I don't care how you think, but you're going to get to 3x minus 2 times x plus 7.
Are there gonna be problems in like 3.1 and 2 that are just like that?
Yeah, just factor this.
Okay.
Yeah, solve. So the thing I would like you guys to know is that you have 3 techniques to solve, right? You have complete the square, you have quadratic formula, and you have factor and zipper, right? The method that I would, or the order in which I would prefer you to apply those methods is think about complete the square for at most 2 seconds. Right, complete the square is a hard skill. If it's not obviously already a kind of grouped up complete the square problem, don't worry about it. After you've thought about that for a second, factor, spend like 30 to 45 seconds, maybe a minute trying to factor. If it doesn't factor quick and easy, go to the quadratic formula. You guys kind of with that?
Yep.
So what I would like you to do is just like have this factor and zipper thing sitting around in your head, because this is a useful skill to have anyway, and it's good to get some practice with it. So try to factor for at least a minute before you move to the quadratic formula.
Cool.
Cool? Questions, things?
Yeah.
Okay, keep in mind that I'm not at factored form yet, right?
Right.
I'm just at almost factored form, which is okay. Cool?
But you can still find the x-intercept from that, right?
Yeah, and you can still find the x-intercepts by taking each piece, setting it equal to 0, and solving. Right? Which will get you to the same x-intercepts you would have up here. Cool? Questions, things?